Okay, hello everyone. So today we'll be doing another example of electrolysis. Today is slightly different, again, as usual. Now we're doing aqueous solutions. So aqueous solutions, when it's aqueous, means that there is water present. Okay, at this time we're doing dilute sodium chloride. So just last time we did molten sodium chloride. Now we're doing dilute sodium chloride, meaning that there is sodium chloride in the solution inside water. Again, inert electrodes like carbon, right? Platinum, carbon electrodes, that means the electrodes do not react. Alright, so now let's go through the steps again. I taught you all some steps. So the first step, label the battery. Okay, after that, label the side. So positive electrode, positive battery, negative electrode, negative battery. Next, flow of electrons always come from the negative side. So flow of electrons goes this way. And then after that, I need to write the ions present in the electrolyte. So I got sodium, I got chloride, and then this is something new because there's water present. When there's electricity going through water, right, the water will dissociate slightly to the H plus and OH minus. This is important. I repeat, right, when electricity passes through the water, there is a bit of dissociation of the water to H plus and OH minus ions. Okay? Alright, now let's first look at the first location, our positive terminal. So the next step is that we need to think who goes to where. So if I look at the sodium, right, sodium is positive, so it will most likely move towards the negative side. The chloride is negative, so it will most likely move towards the positive side. H plus is positive, negative side. OH minus, negative, positive side. So on the positive electrode, I have two options. I have either chloride ion, right, or I have OH minus ion. Now I need to make a decision. Right? How do I make the decision? So there are just several ions. This is the decision making mechanism that you need to do. So for negative ions, for N ions, right, the top, right, number one, most likely to come out would be always your OH minus. Okay, your OH minus is at the top, right? Most of the time choose, and then after that, I minus, Br minus, Cl minus. Okay, in this order, right? Because over here, the Cl2 is the most reactive, so it will rather be in the anion form. Then, for your SO4 2 minus, as well as your NO3 minus, it will most likely not come up. Okay, most likely. Please remember this. So this one, N ions, this is at the top, number 1. And then this is right at the bottom. So 1, 2, 3, 4, 5 at the bottom. Is that okay? Alright, so there are other factors involved, but at this point, I want you all to remember this sequence. The N ion at the top is OH minus. Okay, most likely to come out. So if I need to make a decision here between Cl minus and OH minus, the one that would be chosen is the OH minus. So then a lot of students here, right, they try to go and memorize the formula. But let me just let you know. Think of it just a bit more logically. Okay, so over here, it's not oxygen gas and hydrogen gas. You remember by the products. Like for previously, if it's chloride ion, chlorine gas. If it's Na+, sodium metal. Now this is the only special one that you need to go and remember carefully. OH minus, let's leave a blank here, would produce oxygen gas and water. Okay, this one just need to remember oxygen gas and water. Okay, so now over here we're going to balance this, and this one can be a bit challenging to balance for some people. It will be a 4 here, and then it will be a 2 here. Okay, on the left side I have 4 negative charges. On the right side I got no charge at all. So to make sure that I balance this nicely, what I will do is that I will add 4 negative charges, 4 electrons on the right side. So both sides have negative charges. So how do I describe what forms? So if I have water, I can't see the water forming, but I can see the oxygen forming. So what do I see? I see bubbles of gas formed. Okay, I have bubbles of gas formed. So then I need to explain. So remember my explanation, right? I must say the location, I must say the reactant, I must say the reaction, I must say the product. So the location here is the positive electrode. So at the positive electrode, the reactant is OH minus, hydroxide ion. Now, because I need to choose between the OH minus and the Cl minus, I need to add in another word, okay, because I have to choose. So the hydroxide ion, the hydroxide ion is selectively, then I need to decide, is it reduction or oxidation? So I remember, this one means I lose electrons, right? I lose electrons, lose oiric, OIL-RIG, oxidation is loss, reduction is gain. This is oxidation. So hydroxide ion is selectively oxidized or reacted, right, to form oxygen and water. Okay, remember both the oxygen and water, in this case selectively. Is that all right? Okay, so this is the positive electrode, oxidation. Now, negative electrode. So at the negative electrode, I have two ions that went there, Na plus and H plus. So Na plus and H plus. So when we're talking about negative electrode, right, we will use the metal reactivity series. So if you recall, we learned in metals, right, please stop calling me a cute zebra. I like her calling me sexy goat. And here, this is my hydrogen. And here, this is my carbon. Right? So, the more reactive the metal, the less likely it will want to form. Because if it forms the metal, it will straight away, right? It will straight away react. So, comparing sodium, which is here, sodium is here, and hydrogen that is here, hydrogen is less reactive than sodium, so hydrogen will come out. Okay? Hydrogen is less reactive than sodium, so hydrogen will come out. So H plus is an aqueous. And then I think H plus, what can it form, right? So only thing it can form is H2 gas, right? H2 gas. And then I balance it at 2. On the left side, I got 2 H plus. On the right side, I got no charge. So I add 2 electrons here. This is a gain of electrons. This is a reduction. Okay? So then I describe, if I form hydrogen gas, what do I see? I see bubbles, bubbles form. And then gas produced, extinguishes burning spleen with pops out. So explain, so again location, right? Location at the negative electrode, right? Hydrogen ion is selectively reduced to form hydrogen gas. And the reason why it's selectively reduced is because hydrogen is less reactive than sodium. Okay, so now we know that as the electrolysis happen, more and more the H plus, OH minus will decrease, the H plus will slowly decrease, right? And then the solution will get more, slightly more concentrated. Now, you will also learn that there's these two words called anode and cathode, and today I'm going to show you how to associate that. So, one thing that you must remember is that the cathode, let's write it down here, okay? Cathode is the electrode that reduction occur. No matter what, you must remember that cathode equals reduction. And anode must be oxidation. Cathode is the electrode that reduction occurs. Anode is the electrode that oxidation occurs. So over here, if we see this, the cathode, the positive electrode is where oxidation occurs. So in this case, the positive electrode is the anode because oxidation occurs over here. For the negative electrode, you see that reduction occurs. So this is the cathode because cathode is where reduction occurs. So this is something that you want to only consider at the end. Go through my thinking process and only consider cathode and anode at the end. So how do I sometimes remember this? I will remember this as CRAO, crowd, don't know, right? CRAO, cathode reduction, anode oxidation. Okay, but you always save this for the last. Okay, if you need to use it, use it. If you don't need, I will always prefer to stick to negative and positive electrodes. Is that alright? Okay, so I don't know what other people might say, but I will always keep this to the end because this is the definition. Cathode is reduction, anode is oxidation. Okay, no other definition is correct. Can? Alright, so go and practice. I'll see you for the next one. Bye. All the best.